Now, let's look at another application of derivatives, which is population change. In many real-world situations, we want to understand how a population changes over time. For example, this could be the population of animals or bacteria. To model this, we use a function. Let P of t be the population at time t. So P of t tells us how many individuals are in the population at a given time. The population growth rate is defined as P prime of t. This means we take the derivative of the population function. Just like in the motion example, the derivative represents a rate of change. So here, P prime of t represents the rate of change of the population. In other words, it tells us how fast the population is increasing or decreasing at time t. Now, let's look at an example. The problem says the current population of a mosquito colony is known to be 3,000. This means P of 0 is 3,000. So at time t equals 0, the population is 3,000 mosquitoes. The problem also tells us that P prime of 0 equals 100. This means that at time 0, the population is increasing at a rate of 100 mosquitoes per day. Remember that t is measured in days. We want to estimate the size of the population in 3 days. In other words, we want to estimate P of 3. But notice that we do not have the exact population function. Instead, we only know the current population and the current rate of change. So to estimate the population after a short period of time, we can use the linear approximation idea we learned earlier. Recall the linear approximation formula. P of A plus H is approximately equal to P of A plus P prime of A times H. Now, let's identify each part. Here, A equals 0 because we know the population and the growth rate at time t equals 0. A plus H is 3. So H is the difference between 0 and 3. Now substitute the known values into the formula. We have P of 3 is approximately equal to P of 0 plus P prime of 0 times H. Now plug in the numbers. P of 0 is 3,000. P prime of 0 is 100. H is 3. And we have P of 3 is approximately equal to 3,000 plus 100 times 3. 100 times 3 is 300. And 3,000 plus 300 is 3,300. So our estimate is 3,300. This means that after 3 days, the mosquito population is approximately 3,300. We obtain this estimate by assuming that the population continues to grow at roughly the same rate near time 0. Because we are using the linear approximation, this estimate works best when the time interval is not too large.